Welcome to everyone who's joined us today. I'm Samantha Link, and I'll be moderating today's webinar for Advanced Monitoring in Tight Windows. As we go through the presentation, all attendees will be muted, but please be sure to send in questions through the Q&A feature located at the bottom of your Zoom screen so we can ask MPJ some questions. So I'll go ahead and introduce our presenter, Michael Paul Jenkins, Industry Manager at Gecko Robotics. Michael Paul, otherwise known as MPJ, has been in the NDT space for the past 3 years and has been through 15 turnarounds with Gecko. Before becoming a subject matter expert in the power generation robotic inspection field, MPJ led teams in the logistics industry. His extensive knowledge and experience in robotic solutions for clients in the power generation and pulp and paper industries has exceeded turnaround expectations and revenue dollars saved. Let's all welcome MPJ.
Oh, thank you, everyone. Thanks, Sam, for the warm welcome. As those who are probably wondering, Michael Paul is my first name. It's hyphenated. My mom knew it would be a good selling point being in this industry to have a talking point. But yeah, everyone calls me MPJ. So what we're going to talk about, as Sam said, is advanced monitoring, these tight windows. Basically, is going about inspections in a different approach. Ways that we've done things in the past, how we're doing them now, and kind of what the future looks like. All right. So what we're going to learn about today is understanding that history and the modern take on monitoring assets with those tight turnarounds. Explore the capabilities of rapid ultrasonic gridding, or what we call RUG. Identify advantages and disadvantages of monitoring, use those inspection methods, as well as experience those real-world examples of advanced monitoring and data-dense inspections. But as Sam mentioned, I have a little bit of a logistics background, and to take this time to ask the poll of the audience of a history lesson, if anyone was around when this car was around. It was a 1970s Toyota Corona, and that is the real name. I had to look it up. But the 70s played a pivotal role in the history of trade, shipping, and manufacturing. In this decade, Toyota revolutionized the manufacturing world and the wide adoption of its just-in-time, or JIT, production planning process. In essence, that represents operating with low inventory levels, where raw materials, goods, or even labor are scheduled to arrive or be replenished exactly when or shortly before they are needed in production. Having this system, Toyota could solve some of their problems associated with keeping high inventory levels, free up a significant amount of capital, and reduce operating costs. It could also minimize storage, service, maintenance, and inventory risk costs as well. You're probably wondering what JIT has to do with NDT or inspection procedures. And in reality, what we're trying to talk about is changing the way inspections are taking place. As technology evolves, procedures and processes need to evolve as well. And so the little bit of overlap is, whether it's overproduction, that inventory waste with keeping dead stock, the time spent by workers. You have multiple different parallels between the two, where Toyota wanted to make an immediate impact in the market in the United States. They had to adjust their business plan. And so having robotic inspections, having different types of technologies introduced into the way you all do inspections helps open up new opportunities to save up capital, to bend that O&M curve. Something that we hear a lot over and over again is, how do we limit O&M and how do we get back online faster? So the problem, everyone knows there's known failures, whether it's general thinning, localized corrosion. It's not necessarily uniform. It's sometimes tough to predict or find. Erosion is obviously, it's a rapid deterioration and loss of life expectancy. And some of these vessels, like this scrubber right here, this is a massive search area. Thankfully, there are user groups to help identify those known issues, but there still are some unknowns. And major outages in the power industry, going from every year to every 18 months, every 3 years, even some 6-year major outages. So doing this work in a short amount of time often requires a lot of contractors to be on site or cutting scope in order to fit the timing. But there's also other opportunities to do these types of inspections where you can still get rich data. So maintenance outages, tune-up outages, winterization, summerization. There's different windows where you can do a really comprehensive inspection in a short amount of time. With manual inspections, you run the risk sometimes of not finding the lowest spot. You might find a low spot, but if you don't inspect everything, how can you really be sure? Taking it back to JIT, as that industry changes, new technologies come around, as well as those new procedures. How do you incorporate these new technologies into the way you're currently operating? And are they adaptable for the future as well? And here's another example of that scrubber where it failed because of corrosion in this case. So typically what happens today is a number of things before an inspection, whether it's cleaning for internal inspections, water washing, talk about a boiler, deck cord, or grit blast. Scaffolding round objects in some of these cases is very hard, not the easiest thing to do. Rope access does reduce the need for scaffolding. It's a great resource to send someone down there, get eyes on, feel it, get a little bit of data. The brave men and women that do that, I myself am not one of them. But when you run those spot checks, how do you repeat that? You might have a different operator in the next time. About repeating that is really important, and that's kind of where these technologies come into play. Currently, the big hot topic that we come across is drones. So it's a great application for visual inspections. In the power industry, a lot of times you'll have a forced outage, you'll go up and you'll check some superheats, you'll go out there and do maybe a mass inspection. They help with that speed. I myself have seen it firsthand, amazing tools and technology, but sometimes you really need that data. And so that's kind of where the robotic side comes into play. For those of you who have not seen these videos in the past, this is just going to go a real highlight of rapid ultrasonic grading, like I said, RUG. So the traditional methods sometimes can be slow, can be dangerous. Getting what you need in the window you have is a problem sometimes. Scaffolding is a cost associated with that, usually a large cost, and the data that you're provided is usually low in density. RUG is basically can do an inspection, most inspections in one shift, whether it be cones, spheres, tanks in general. And with that comes 2 individuals, 2 NDT techs, and 1 robot. Depending on the setup, you can have little to no scaffolding as well. And you're talking about 1,000 times more data that can be recorded and reviewed down the road. So as I said, 10 times faster, 1,000 times more inspections. Here's some examples of assets we've inspected to give you a little bit of sense of timing. Rapid gives you an idea of the speed. And those who would be interested in non-confined space entries inspections as well, those are technologies out there, not just with Gecko, but other companies as well. So again, let's talk about rapid ultrasonic grading. Like other UT methods, RUG captures that raw A-scan data, which could be presented in a B-scan or a C-scan mode, or used to create a visual representation in those 3D models. However, RUG is capable of capturing multiple A-scan data points at a much faster rate than those traditional thickness measuring techniques. As such, the speed of the coverage is greatly increased over methods utilizing a single thickness probe. The spacing between those probes, the frequency of recording varies depending on the amount of thickness data that's needed. And I threw a lot of terms out there: A-scan, B-scan, C-scan. There's probably other scans out there too. A-scan, think of it as a signature of sound, right? A thickness value associated with that. B-scan is viewing those A-scans across the run or distance. So in this visual off to my right, this is the B-scan that comes with the inspection. You can see as we go to the right, thicknesses come down, dip down, come back up. So right there, the operators know that there's a potential issue, and you can either go back and validate that with hand, or you can validate that back in the office and give you the final C-scan report, which is what you would see with the robot on the left. But all that goes to a 3-step validation process. So there's ASNT level 2s, level 3s, procedures are written. Robots, while they're useful, reliable, and safe, they still need humans to operate and maintain. From calibrating transducers, validating those readings, as well as writing those reports. The robots are a tool. Granted, they're a really impressive and helpful tool, but still a tool. You can buy some tools. You can also rent these tools, lease them, or you can hire a service company to use their tools, something like Gecko. While it would be nice to just throw the robot on your boiler, tank, silo, pressure vessel, come back a few hours later, kind of like a Roomba, you still need good operations teams. And to talk a little bit more about these pictures, being able to see these A-scans live, being able to audit them, go back and look for context, and then when the data team uploads that, having an interactive approach, portal, go in, look a little bit more instead of just a written report. So let's talk about those advantages as well. Whether it's delta mapping, fast, adaptable, It gives you peace of mind and less access. Like the cams when you're talking about delta mapping, cams on a scrubber, something that is repeatable. Going back and knowing this object, providing a thickness measurement, something that is going to be reliable and go back and forth. But you can also do certain things like different assets where in a scrubber, like the one of the pictures I showed before, you already know the areas that you should look for, right? That spray zone. So circumferential runs with the robot helps find that. You think about how you're inspecting now. Are you able to lay over that data from inspection to inspection that is accurate within a few centimeters? Maybe that's not important, maybe that is important, but are you able to do that in a fast turnaround, right? So we're talking about robots that can travel anywhere from 1/2 foot to 1 foot a second. So inspecting certain areas like just the lower slopes of a boiler, just the slip lower lanes, just the fill line of a tank, taking the benefits of the robot with its data collection and speed and making that work for your inspection plan. So you're talking about anywhere from 1 to 80 readings per square inch when you're talking about the peace of mind. And then less access needed means it's safer and easier to work with. The other things to consider is obviously the cleaning that we talked about earlier, the schedules and the budgets. Maybe I can't fit it during this outage, but maybe I'll be offline for a few days. Talk about the cleaning and how we can incorporate technologies. There's companies out there that can do tank inspections, tank cleaning with no human entry, just a robot in there. Not all cleaning companies are created equally too. There's technologies, there's different investments in those cleaning spaces that really separate the companies and provide a better service. Now we're gonna get to the fun stuff, the actual real world examples. We worked on a circulating dry scrubber up in Wyoming, and the customer came to us and said, hey, we know about these concerns. Don't really want to spend a lot of money scaffolding it. And even if so, there's a lot of things to be concerned about where maybe more data density is needed. The problem is we only have a few days to do this. So we worked with them, tried to figure out the best time for when they could come offline, gave them the information for cleaning. And they said, hey, just go in there for 3 days. That's the time we can give you and get as much as possible. And so we said, hey, we probably could do that with 2 inspectors and 1 robot and got it done in 3 days. Identified those areas of concern, gave them an idea of where they needed to be at in 5 years and 10 years, and got some feedback from the customer as well. Cleanliness is always a big issue when you're talking about UT, and there was those expectations on how clean it needed to be. But we worked through it and helped them, and we're able to work through getting from the cone to the shell. So letting them know that, hey, there's probably going to be a little bit of access needed. This is where we're going to need to get that. Maybe your scaffolders can come overnight. And so normally it would probably have taken 2 weeks to do this inspection from the feedback that we got. And to be able to do that in just a few shifts really saved them a lot of time and money. And going on to that CDS, this is the type of data that we captured in the working environments that our inspectors were working on. You can see the robot on the bottom working on the bottom of that cone, and the data that we collected. It's very vibrant, very rich in color, so you're getting great coverage, and they were not expecting this much degradation. And so being able to show that and be able to help them, not only did it prevent the failure like you saw in one of the first slides, you were able to figure out and really set your budget to figure out when this is going to be needed inspecting, because they've already inspected this in the past. So they're able to take that information and apply it to this and make their own calculations. This is a little bit more in depth on the delta mapping. This is something that's really important. Being able to go back from a first inspection to the next inspection and really monitor those vessels over time in a way that's going to give you the speed and the data that you're looking for. And so, as you can see in this, we did an inspection in 2019, came back, did it in 2020. And when you click on that cell, you know exactly what that wall loss looks like. Because of that encoder on the robot and those start points, if you're accurate within literally centimeters. For those of you with the boiler industry, I want to highlight some of the advantages of what the robotic inspections can do. So this is a 50 megawatt biomass boiler out in California. They came to us wanting to do UT thickness on all 4 water walls, as well as magnetic induction on all 4 water walls, because there was a lot of metal spray and canal on these boiler tubes, and as a CFB, erosion is they're highly prone to. And so they came to us, we said probably could do this with 3 robots. 12 inspectors, 2 shifts, and 2 shifts working through the night. So being able to get this done in one day. And as you can see on the right, I took this picture when I went out on the job, about $4,000 worth of shipping of Pelican cases, but too much to the customer's delight. We were able to get in there and not only, oh, and I think my thing froze. All right, yeah, there it is. So get them the information they need and come back and improve that reliability. The issue was that the current outage schedule is already set. Literally every hour of every day was accounted for, and there was a lot of shuffling that was needed. And we're talking about a 10-day outage. However, they needed to control their spending, and in order to do so, Gecko was able to provide them with a working plan, like I said, not just for this year, but years to come. This scan was identified for them to plan better, understand variance in their fuel, take control of the metal spray application, make that 5-year plan, and then to bring us back in the future to help that Delta map inspection. So we're preventing tube leaks in general, curving their spend on NDT and maintenance, as well as forced outages. This is a fun one too. This is about shifting on a dime. Basically, there was a refinery down south that was doing AUT, and they found some initial readings that caused them concern. Thought they would have to derate this tank. In order to finish this inspection, it's probably going to take another week. However, that being said, they called Gecko. It was July 4th weekend, and we were able to get out there in about 8 hours and take about a shift to inspect this. And to give you signs, we're talking about 80 foot in diameter, 40 feet tall. Be able to push that lifespan of that tank back 5 years and get it online in time was very valuable for them and an appreciative customer as well. So with AUT, and I'll have a slide to show about that a little bit more, you're talking about really good data density, but there's a time associated with that to get that density. So you have to ask yourself, you know, what's my level of concern with this? How much data do I really need? There's technologies out there that will give you great density, but it's going to take a while and it could be costly. There's obviously inspection techniques that aren't going to take as long, but the data is, you know, lacking. Finding that middle ground that works for not just the customer, but for everyone involved is where some of these technologies come into play. Oh, fun stuff. So now the fun stuff as well. Rapid AET, conventional AET. For those of you who are not familiar with AET, it's highly accurate data as an important tool for implementing like risk-based inspection programs, fitness for service analysis, and remaining useful life programs. These advanced NDT techniques are also widely used in capital projects, turnaround, schedule planning, and shutdown outage projects. So rapid AET is a dense coverage like RUG, but at a much higher resolution. This is a perfect tool for mapping out corrosion where more data is needed for fitness of service determination. You know, broadly speaking, rapid AET uses phased array probe that can have about 128 transducers. So it's a combination of hardware movements, software controlled pulses that permit a much faster AET system. As you can see, 3 minutes to run this 10 feet versus 13 minutes. And as you compare the data, you're talking about rapid AET and AET. The rapid AET, very rich, very good coverage, being able to figure out what's going on, as opposed to the AET, where there is a little bit of loss of coverage. These white spots represent that. And you can pair RUG with other technologies. So this is a case of a pressure vessel where we use RUG, rapid AET, and phased array. For that turnkey solution, being able to do an external inspection as opposed to an internal inspection, safer, and it was less access needed as well. So other resources for these types of technologies, obviously a company like Gecko is going to have a lot of this information, not just on RUG, but some of the partners that we work with, as well as inspectioneering. I know I saw some of the attendees on this list. I'm sure you use this website a lot. It's a great resource, not only for people like myself, but I try to share this with as many customers as I come across. I like to think of it as the Wikipedia of NDE. It's very helpful, and they have a journal, still hard copy journal that I like to read every time we get it. I think it's a once a month, if I remember correctly, or maybe once a quarter. So with that being said, I'm open to any questions, comments, concerns, anything like that.
Awesome. Thanks, MPJ. So we do have some questions in here. I do want to remind everyone, if you do have a question, please feel free to send it through the Q&A feature down at the bottom of your screen. But we'll start off with this first one here, which is, what is the required level of cleaning for the TOCA system to measure with the highest accuracy and reliability? Is there a specification that they can refer industrial cleaning contractors to?
Rick, that's a great question, and it's a question that I've not necessarily struggled with, but it really comes down to that data that you need, right? The cleaner, the better. It's called a spade a spade. When you're working with UT, you don't necessarily need to be white metal, but you need to be, clean. What you eat off of it is the good parallel I always say. But I can show you a little bit more examples if we want to go back to the previous slide. Do this. So when you're working with UT, obviously, if there's any rust or anything that's peeling off like paint, you're going to lose sound through that. But for the level of cleanliness, maybe if it helps, if there's a particular asset you had in mind. Rick, do you have a particular asset in mind? How about this, Rick? I will find the examples of the cleaning and we can connect to share with that. But basically, if we're talking about a boiler, in many cases, high pressure water wash, talking about 10,000 PSI, 250 gallons per minute. Those whirlybirds that drop down, those are clean enough for us. Tank floor, a little bit different. Quinn, if you want to add any of your experience on the cleaning side in the oil and gas industry, feel free to do so. But yeah, I mean, it needs to be clean. We're talking about that if you want to get the most out of the data.
Awesome. Can you talk a little bit more about the delta mapping and reproducibility? Is this an advantage that every rapid ultrasonic gritting inspection gets?
Yeah, so if you're talking about like a boiler or a tank, we have our standard operating procedures or a scan plan where we'll start at the same known elevation or staying the known, call it a manway. And being able to do that repeatably because of that encoder, or in some cases we're doing non-confined space entries, we have automatic tracking system on there, like on the video, we're able to know exactly where we are. And so being able to go around and delta map that is part of every rug inspection, as long as we've inspected it in the past. Now, you're more than welcome to use data from previous inspections, go onto our portal and try to put those previous inspection thickness measurements in there yourself and use our information and the previous inspection companies and try to figure out if that matches up. However, because of our procedures, any type of inspection that we do has the ability to do that delta map to go back and forth. So talking to a utility that we did in a boiler inspection 4 or 5 years ago, checked with our data team, and yes, we can absolutely do it.
Awesome. And then looks like Rick is wondering about the cleaning for boilers, condensers, industrial heat exchangers, etc.
Yeah, Rick, if you sign up with your email, I actually have a perfect document I can share with you for that. That'll give you a real highlight overview of the level of cleaning that we require.
Awesome. Can you talk a little bit about Gecko's involvement in formulating the actual inspection plan for customers? How do you go about understanding their expectations and needs?
Yeah, that's a great question. And as someone who started in this industry 3 years ago, I wish I would have known what I know now. And that really takes a deep dive, right? You don't need to do 100% inspections of your vessels unless 100% is needed. So you really need to understand the customer's needs, wants, working within their budget, working within their time, and being able to formulate that plan. We're never going to mislead or lie to you. We're going to tell you what we can do, what our limitations are, and figure out that makes and that works for you. So one of the things that we've really invested on is bringing industry vets who have been doing this for years, pairing their brains with the technology that we can build, and talk about not only formulating an inspection plan, but an action plan going off of that, taking that data, taking the speed, working with other vendors from cleaning to inspection to repair companies and pairing that all together. But you got to have a conversation to figure out how to help the customer, because what works for one company is not going to necessarily work for the other. There's a reason why they're competitors, right? They have a different way of going about business. They might sit on the same boards, or they might sit in the same users groups, but they still have their own way of doing it. Working in the paper industry, I'm sure Quinn can speak to this as well. It's a lot different than the oil and gas industry. Not saying one's better than the other, but it just have a different way of doing things. And so while I say 100% is not the right way, it's because maybe you can just do 4 drops in a circumferential run in those low areas, and that's good enough.
For sure. And if I can chime in here just a little bit, it depends on the results of your previous inspections. Do you have known areas of damage, or would it be beneficial to go ahead and scan the entire asset, given that you've only been spot checking it for decades, perhaps? So you want to make sure you're monitoring the appropriate spots, and if it's worth the investment to make sure that your critical monitoring locations are the critical monitoring locations you need to know about, that would be an example of where more coverage would be necessary.
Thank you, Quinn.
So a lot of people have seen the pictures that you kind of have in your presentation. Is it pretty common to not need scaffolding for your inspections?
Again, it goes back to what you're inspecting, right? So talk about a boiler. As long as we know the bend radius, as well as angle of transition, most of the time we can make the transition from the slopes to the water walls. But in order to get to the sidewalls, you do need some type of access, whether it be scaffolding or chicken ladders. For tanks, if you're doing it and there's no stiffener bands or anything like that, yeah, you don't need scaffolding. Sometimes a JLG is sufficient enough, but it really takes someone like myself, someone like Quinn, and operations teams to get you that information ahead of time. So doing a walk down is always very important, because in some cases you might anticipate you don't need any scaffolding. You get there, things don't always match up on the drawing. Construction drawings are not always the same as the drawings that we're given. So going in there, getting eyes on and telling them exactly, and that's something that I've done, and I'm sure Quinn has done as well, is take those drawings and build a scaffolding plan for them if it is needed. But for most inspections, I would say, little to no scaffolding is needed. But again, it depends on what you're targeting.
Great. And so you kind of talked about a few different robots, in your presentation all throughout, specifically for corrosion mapping. How would you explain how you would choose one over the other?
Yeah, so I think it comes down to how much data is needed and how much time they have, what kind of asset it is, whether it's piping, whether it's a boiler, whether it's a tank shell. If you're really looking for that dense data, as I showed earlier, the AET, the rapid AET is probably your best bet. But if you're looking to do, just corrosion mapping localized corrosion mapping, maybe it's a TOCA 4, which is the robot with 24 to 32 transducers that gives you an inch resolution. Maybe it's another one, we're talking about tank floor, and you need 1/4 inch resolution. So, pretty much the robots are the same outside of the AUT. But again, it comes down to the customer's needs and wants. Do they only need, a general idea, or do they really need to figure out if they have ID defects, soil side corrosion, top side corrosion? These questions really help us determine what's going to provide the best solution to the customer.
For sure. And if I can chime in here again, in the context of damage mechanisms, if it's something that's a general corrosion, then a faster, lower data density solution would be good, which would be the RUG robot, or the rapid ultrasonic gridding robot you see on the screen now. This could be either an inspection unto itself, or should damage be found, then you could have some highly targeted, denser data, slower solutions deployed on that same project, just to make sure you're capturing the extent of the damage in the places that you find your screening.
Well, in many cases, you do have to go back and revalidate that. Even with like MFL or something you do on a tank floor, you still have to go back and validate that. When you're talking about the power industry, under deposit corrosion, acid phosphate corrosion, hydrogen damage, there are certain utilities that I've worked with that have a procedure to quantify it, whether it's hydrogen damage or under deposit corrosion. And there's some who just want to know about under deposit corrosion and let them make those decisions. So again, taking what we're talking about is there's a good way to go about it, and then there's another way, a further step, but not everyone always needs that. Sometimes it's good enough to just get that information and then do with it what you will.
Awesome. Thanks, guys. We'll wait a couple more minutes here just in case anybody else has any more questions they'd like to send in. Otherwise, I did want to remind everyone that we will be sending out the recording to this webinar out to everyone after we've exported it. That way you guys can rewatch it, send it to colleagues, do whatever you'd like with it. And then otherwise, thanks so much for joining us today.
Thank you, everyone. Do we have Rick's email, Sam?
We do.
Good. I appreciate everyone asking the questions, and for those names that I recognize, thanks for showing up and supporting us. If there's any other questions, feel free to reach out to myself, Quinn, take a look at the website. And again, go back to the inspection area and those resources out there. I hear about a new technology every day. Every day, I'm trying to figure out how can we make that better, or how can we evolve that with our customer base, whether it's a hardware approach or a software approach. Big things are coming in this industry, and it's not just Geckos, multiple companies doing this.
So it looks like somebody's asking, where are we based out of?
Oh, so we have two main offices. I'm located in Pittsburgh, and we have another office, which is more of an operational NDT office, which is in Houston. For those of you in Houston, it's a great office. I encourage you to check it out. And for those close to Pittsburgh, we're currently at an office, but we'll be moving downtown here within the next few months to a really nice office. And if you're baseball fans, it's right across the street from the Pirate Stadium. So it's not the best baseball team, but it's still Major League Baseball.
So somebody wants to know, does Gecko use AUT or only rapid AUT?
Oh, we use both.
I do want to point out that we use a lot more rapid AUT than the AUT that you're probably familiar with on this recording, or if you have AUT being used on your sites. Just the data advantages with the extra data we're collecting, we're able to prevent a lot of miscategorized calls that might either require some rework or might be a false call that takes that asset out of service at an inconvenient time for the site. And then I don't need to explain the advantages of speed being its own reward. So we're definitely trending in that direction.
Great, thanks, Quinn. So we'll go ahead and end the webinar here. Again, thanks everybody for joining us today. Reach out if you have any questions. Otherwise, we'll be sending the recording shortly.
Thanks, everyone.